So when last we met, we were talking about law of sines. And we were dealing with finding those missing parts of triangles that have no right angles. So today we're going to look at, I want you to find the missing pieces. So let's say I give you that angle A is 32 degrees. I don't know angles B and C. Side A is 21 feet. Side B is 36 feet. Side C we don't know. Now before I start looking at this problem, is this enough information to solve this problem?
Yes.
Theoretically it is, but what's the issue here? Remember, here we have two sides and one angle. And there's a potential for problems there if what happens? Close. Side opposite the angle is smaller than the other side. In this case, is that true? Yes, it is. Side A is opposite angle A, and that is the smaller of the two sides. So there's an issue here. We need more information. So I'm going to tell you that angle B is obtuse. That should be the information you need. I want you to solve that triangle for me quick in your notes. Okay, so we know that angle B is obtuse, so I'm going to draw it like this. So A, B, C, little a, little b, little c. So this angle we know is 32 degrees. This we know is 21 feet. And this we know is 36 feet. So we start out with the side and its opposite angle. So that's going to be the 21 feet over sine of 32 degrees. So then we're going to, from there, on the other side, what do we put on there? (36) is the only other side we have, over the sine of B. So we are going to cross multiply and divide, but of course what we're going to get here is not angle B, it's going to be the sine of angle B. So we're going to do sine of 32, make sure you close that parentheses, times 36 divided by 21. Now the biggest thing here is this has to be smaller than 1. If it's not, we have issues. It doesn't form a triangle. Here it is, 0.9084. Now we have to do the inverse sine to get to the angle. Unfortunately, because this is obtuse, what we get here for the inverse sine is not going to be the angle. Let's get it here and we'll go from there. So I'm just going to do second sine, second answer. I get 65.29 degrees. That is the supplement of our angle. So to find the actual angle, it is 180 minus 65.29 degrees, which makes that 114.71 degrees, which makes angle C up here, I'm going to have to draw it up here because I ran out of room. I should have made my triangle bigger. Makes angle C up there 33.29 degrees. Correct? How did I get angle C? Yeah, I added them up and it subtracted from 180. 180 minus the 32 and the 114.71 leaves me with 33.29. So now, all that's left to find is side C. Before I find it, what do I know about its size? Bigger than 21, smaller than 36, right? Because this is 32 degrees, that's 33 degrees. It's got to be slightly bigger than the 21. So let's start out again. We've got 21 feet over the sine of 32 degrees equals, over here we don't know, we're looking for side C, over the sine of 33.29 degrees. So again, we are going to cross multiply and divide. So 21 times the sine, 33.29, make sure you close that parentheses, divided by the sine of 32, 21.75. And that makes sense. It is just slightly larger than the 21. Any questions? So that's probably the most difficult problem we could get for a law of sines, is when you know that this angle here has to be obtuse, you have to remember to do the supplement of what you get when you do that inverse sine. What if I tell you that A is 43 degrees? I don't tell you angles B and C, but I do tell you that side B is 41 feet and side C is 36 feet. I have two sides and an angle still, but here the issue is I don't have a side opposite the angle. If I draw this out, I literally get a picture like this. I have this angle here is 43 degrees. I have this side here is 41 feet. This side here is 36 feet. I don't have a side in its opposite angle. I cannot use the law of sines here, which means I must use something different. That something different is the law of cosines. Now, the beginning portion of the law of cosines is going to look really familiar to you. In fact, I should have relabeled this. I labeled it poorly here. So what I'm going to do is I'm going to do this. I'm going to label this angle that I know as angle C. So this is going to be angle A. So this is going to be side C, and this will be side little a. So I relabeled it. Because the standard form of the law of sines looks like this. The length of side C squared is equal to the length of side A squared plus the length of side B squared. Does that look familiar so far? That's a Pythagorean theorem, isn't it? A squared plus B squared equals C squared. But this is not a right, if C were a right angle, that would be it. But C is not a right angle, so there's an adjustment factor. So minus 2 times A times B times the cosine of angle C. The law of cosines is sometimes called the generalized Pythagorean theorem because it applies to all triangles, not just ones with a right angle. So to solve for C here, I'm going to move down here. C equals, what's side A? C squared, I should say, equals. What's side A? 36, right? So 36 squared plus what's side B? 41, so 41 squared. Minus 2 times 36 times 41 times cosine of 43 degrees. Now, we could do this all out step by step, but we can put that all in our calculator all in one step, so let's do it. 36 squared plus 41 squared minus 2 times 36 times 41 times the cosine of 43 degrees. I hit equals. I get 818. Now that is still c squared. 818.04. To get c, I still have to square root that. So I do second square root, second answer. 28.60. So c is 28.60. Now that I have that, guess what? I now have a side and its opposite angle. I have the 28.60 over the sine of 43. Now, you might wonder, does it matter which other side I use first? And the answer is yes, it does. I always want to use the smaller of the two sides first. So which one am I going to put in there? 36 feet. So that's going to be over the sine of angle A. Why do I always want to use the smaller side first? Well, because the longest side is across from the largest angle. And there is a possibility that the largest angle of this triangle could be obtuse. We don't know for sure. But we do know that there could only be one obtuse angle, right? So we do know that the next largest angle has to be acute. So the reason we're doing the smaller of the two sides is we know that since 36 is not the biggest side in the triangle, that it must be opposite an acute angle. So we will cross multiply and divide here. Sine of 43 times 36 divided by 28.6. What was that? 0.8. I get 0.858. All right, sine of 43 times 36 divided by 28.6. No, 8.8585. Oh, that'll do it. Yep. So then, of course, A is the inverse sine of that 0.8585. Again, I'm going to leave it in the calculator. Second sine, second answer. 59.14 degrees. So A up here, 59.14 degrees. B is going to be found by taking 180 and subtracting those two. Well, those two, if I add them up, is 102.14. So this is 77.86 degrees. So I know it's an acute angle because it is the angle sum. So I always shy away from using that largest side because there's a possibility that could be opposite an obtuse angle. Let's do one more problem here. And I am going to slow down this example for you so we can go step by step. So I'm going to give you this angle here as 38 degrees. And you'll notice this time I did not go out of my way to label them as the angle is angle C. Because I'm not going to coddle you like that. We have to be able to adjust the formula no matter which angle it is. And let's say that this side over here is 52 inches. And this side over here is 32 inches. Step one, of course, first thing we need to know is we have two sides and the angle between them. Since the angle is between them, that's saying there's no side opposite the angle. So that tells us we have to do the law of cosines. So the first thing we always do is check to see if we can use the law of sines. In this case, the answer is no, we cannot use the law of sines. Step 2. We're going to find that opposite side. Now in this case, the opposite side is side A. So it's going to be A squared equals 52 squared plus 32 squared minus what? 2 times 32 times 52 times the cosine of 38 degrees. You'll notice these two are just the two sides that I have. Doesn't matter whether they're labeled A, B, C, whatever. Those are just the two sides that I'm given that are next to that angle. Here I actually switched the order, doesn't matter. I just had to put those two sides in there. Now I'm going to shorten this up one more step. I'm going to put a square root around this so that takes care of that A squared. So I can enter this in my calculator all in one step now. Second square root, and most of your calculators can do it except for Richard's. So second square root, 52x squared plus 32x squared minus 2 times 32 times 52 times the cosine of 38. Make sure I close that parentheses. Some of your calculators, you'll have to hit a second close parentheses to close off the square root. It equals, I get 33.249, 33.25 for A. I'm going to let you guys do that calculation, see if you can come up with the same thing quick. Got her? Tate, she work for you?
Yes, that's what I got.
Okay. Step 3, we're back to the law of sines, and we're going to use the smaller side. That part right there is very, very important. Use the smaller side. So what do I want to set up for my law of sines here? I have to use the 33.25 inches. Over what? Sine of 38 degrees. That's the only pair that I have where I have a side in the opposite angle. That's why I had to do the cosine, was to get that side. Law of cosines, to get that side. Which other side do I want to use first? 32. Why? Smaller side. That's going to be over the sine of B. Very good. So we cross multiply and divide. Sine of 38 times 32 divided by 33.25. Sine 38, close that parentheses, times 32 divided by 33.25. 0.5925. We do an inverse sine to find B. So second sine, second answer. 36.34. Now is that our angle, or do we have to do the supplement? That is our angle. That is why we used the smaller side. So we knew that we used that was our angle. We didn't have to worry about whether it was a supplement or not. Now we have to find angle C. How do we find angle C? That we subtract. 180 minus 38 minus 36.24 gives us 105.76 is angle C. So there, C was obtuse, but it's just barely obtuse. 90 degrees is the right angle. So it's been really hard to figure out from the picture, is it obtuse or is it acute? In fact, this picture looks very acute. Okay, so it's going to be time for you guys to try one on your own. So I should put in the step 4. That's to subtract to get third angle. So those are our steps. We subtracted to get the third angle. That's how we got the 105.76 up here. If I tell you that angle C up here is 29 degrees, side A we're going to call 18 feet, side B over here we're going to call 10 feet. What is step 1? Well, the first thing is, can we use the law of sines? No, we don't have the side in the opposite angle. So that means we have to do law of cosines. We should always look to see if we can use law of sines. In this case, we cannot. So now you're right. We find opposite side, right? How do we do that? In fact, before you answer that, in your notes, find that opposite side. Which side is the opposite side here that we're looking for? C. So we're going to find side C. So write out the formula for that in your notes and find it, and we'll talk about it in a minute. So it's C squared equals what? 18 squared plus 10 squared. 18 squared plus 10 squared minus 2 times 18 times 10 times the cosine of 29 degrees. Perfect. So what did you get for C? What's that? 10.45 feet. Did everybody get that? Let's punch her in here. Second square root. I'm getting the 10.45. Yep, 10.446. Did you find your mistake?
Yeah, there it is. I punched something wrong.
Okay. Step 3. Find that smaller angle. In your notes, do it. So what do we find here for this one? How do we set it up? First of all, we had the 10.45 that we just found over sine of 29. 10 over sine of B. Cross multiplied, we divided 0.464. 0.464. Then we did the inverse sine to get the B is 27.66. Sound good to everybody?
I like it.
So now, what's our last step here? Step 4. Perfect. We find that third angle. So we add those two up. We have 56.66. This is going to be 124.34. Correct?
Yeah.
Why would you ever need something like this?
To
surveying, it happens a lot. Let's say that's a lake. And I have a point right here and a point right here. And I want to know what's the distance between them. Well, I'm going to pick a third point over here somewhere. Using that good old Theodolus thing that we talked about, right? I'm going to set it up, and I can find the angle here. Oh, let's say it's 49 degrees. Let's say that this length here is 210 feet, and this length over here is 185 feet. Find the distance between those two posts, or whatever they are. I'm going to let you guys try this one on your own. I think you guys got the formula down now. So if I call this D here, how do I find D? Okay, D squared equals?
We can go with 210 squared plus 185 squared minus 2 times 210 times 185. The cosine of 49. Damn.
There it is. So square root of 210 squared plus 185 squared minus 2 times 210 times 185 times the cosine 49 degrees. Yeah, 165.38. That's actually not squared, that's just D. No, it's just a pond. But you guys get the picture, right? So a little bit of homework here to finish off our first hour. Of course, in the big book, page 757, exercise 36-11, 1 through 12, the odd. Then page 761, exercise 36-13, 1 through 12, the odd. Let me double check these pages quick. I've got like 2 different pages scribbled down here. Make sure I grab the right set. And of course, I did grab the wrong set.
Pages?
Of pages, yes. It's actually page 787 and 792. Give you a few minutes to work on those. There are going to be a couple of things I'm going to discuss in 792 before you get too deep into it, but I want to get you started on them. We'll talk about more in a little bit. One of the other things I want to go over with this law of cosines is this case here. I'll draw this a little bit. We ran into this earlier in the year, actually ran into this last semester, where we have all 3 sides. Like this, 30 feet, 40 feet, 50 feet. I have none of the angles. Now I could find the area. We use that Hero's formula or Huron's formula to find the area of it. But what if I want to find my missing angles? Well, I'm going to pick an angle. I'm going to pick this one here. Right? Doesn't matter which one I pick. I'm going to label it so that's angle C. Well, I still have my formula. C squared is equal to A squared plus b squared minus 2 times a times b times the cosine of angle C. Now the difference is the piece that I don't know is C, is angle C. But I still put inside C is 40 squared. A is 30, and that's going to be squared. B is 50, that'll be squared. Minus 2 times 30 times 50 times the cosine of C. Now basically what I'm going to do here is I'm going to treat the cosine of C as my variable. That's like my x. Everything else I can simplify. So the question is, what can I simplify? Well, on the left side over here, I can do 40 squared is 1600. On the right side, I can actually combine these. 30 squared is 900. 50 squared is 2500. That adds together to get 3400. Why can't I combine that with this? Because that's multiplying. Yeah, it's multiplying the cosine C, so I got to take care of that. But I can multiply those together. So this is minus 2 times 30 times 50 is 3000. But that is still times the cosine of C. So right now, this is just like having 19 minus 2x, something like that. Let's say this equals 7 or whatever. To solve this one here, I would subtract the 19, right? And then I would divide by the negative 2. We'll do the same thing here. I'm going to subtract the 3400. That gives me negative 1800. That's gone. Over here I have negative 3000 cosine C. Any questions so far? I know I'm kind of faster so far. I'll pause. We're good? Now to find cosine C, we got to divide by the negative 3000. So I've got 0.6 equals cosine of C. So then, of course, it is just a inverse cosine of C. Second cosine 0.6. 53.13 degrees is C. What do you think? Not horrible? Now, of course, we have a side and its opposite angle. I've got my 40 across from the sine of 53.13 degrees. Which side do I want to use next? This, yeah, the smaller one, the 30 feet. So it's going to be across from sine of A. If I cross multiply and divide here, I get what? Point. So sine of 53.13 times 30 divided by 40. 0.6 again? So the inverse sine of 0.6 is what, 26.87 degrees? Does that look right? $36, you're right. Yeah. That one's 90 degrees if we subtract it. That actually was a right triangle. I was just messing with you. If you'd have done a squared plus b squared equals c squared, it would have worked out. 30, 40, 50, 3, 4, 5. I was waiting for somebody to yell that out when we were going through it.
I thought of what I said too many times.
Okay, so I'm going to have you guys try to find a missing angle for me. Yeah, fun, fun. let's say that this triangle here, I can label it however I want to. Let's label it this way. Let's call this over here 32 inches. This one down here 35 inches. And this one over here we're going to call, let's call it 18 inches. Find those three angles for me quick in your notes. So we start out, we're going to pick which angle we're looking for. Which angle did you guys look for first? You picked C. Good choice. So then we're going to set up what side goes first here in our thing. 32 squared equals perfect. So we fill in everything else according to our formula. So 32 squared is 1,024, right? 35 squared is what? 1,225? 35 squared should be 1,225. 18 squared is 324. 2 times 30 times, or 2 times 35 times 18 is what? 1,260, I believe. Times the cosine of C. So you just combine these two, I believe, right? So I got my 1,024 equals 1,549 plus 1,260 cosine C. Minus, thank you. I don't know why I put that plus in there. It should be minus in both cases. And then we must subtract the 1,549. Because we can give us 525 negative. And then we got to divide by the negative 1,260, right? So cosine C equals that number. So negative 525 divided by negative 1,260. You got 0.4167. Now we do the inverse cosine. See that C equals second cosine, second answer. 65.38 degrees. Yep. Now, of course, I'd want to find angle A next because it's the smaller of the two. What'd you get for angle A? 30.75. That's just going to be 32 over the sine of 65.38 degrees equals 18 over the sine of A. So you will cross multiply and divide. Sine of that angle times 18 divided by 32 gives you the 0.5113, and then the inverse sine gives you the 30.75 degrees. Then, of course, B you find by just subtracting. B is what? 96. So this is going to be 83.87, I believe. What do you think? Better than a sharp stick in the eye? Okay. So along with those 2 pages I gave you before, I also want you to look at page 797 in your book. This is going to be exercise 36-14, 1 through 24, the odds. It's some applications of this law of cosines. And like I said, you got this quiz to do for Thursday. Thursday, you'll have your whole hour and a half to start on a unit test. You will get to take it home and finish it. But yes, there is a unit test coming Thursday to a math class near you.